we are going to learn physics. Our topic is force and motion. We do different activities such as running, jumping, playing and many more work. All of them need force to do. So this is a book. It is on the table. It does not move by itself. When I apply some force on it, it changes its position. And this is a toy car. To move it, I apply it to push or to pull. To push or pull is called force. In other words, to push or pull that changes or tends to change position of a body is called force. Force is equal to mass into acceleration. That means a body of mass m move with an acceleration of a is called force. SI unit of force is Newton and mass is kilogram. Acceleration is meter per second square. Now what is 1 Newton force? 1 Newton force is that force in which a body of mass 1 kg move with an acceleration of 1 meter per second square. SI unit of force is Newton. Spring balance is used to measure force. Now force effect on some bodies. The effect of force are it can change state of a body from rest to motion. Now this toy bus is in motion. We apply force on it to make it in motion. And second effect is it can change a body from motion to rest. This ball is rolling on the ground. If we apply force to stop it, it changes position. So force can change from motion to rest. Now third effect of motion are it can change shape of a body. This is a balloon. While I am going to press it, the shape of the balloon changes. Other examples of force can change shape of a body is your mother make roti for you. She applies some force on the dough of flour and make a roti. Force can also change speed of a body. While cycling, you apply more force on the pedal to make it run faster. To make it slower, you apply brakes. So you can also apply force to make the speed of a body. Force can change direction of a body. While playing cricket, bowler throw the ball in one direction and batsman hit the ball to change the direction of ball. So force can also change the direction of a body. Now this ball is moving in this direction. When we apply force, it changes its direction. Our next topic is rest and motion. When we see around us, we found bodies are in different conditions. Some of them are in rest and some are in motion. I am changing my position. I am changing my position while teaching. So I am in motion. You are watching my video sitting on the chair. So you are not changing your position. So you are at rest. Those bodies which are changing their location relative to other body are in motion. For example, boys running in the park, vehicles running on the road, and those bodies which are not changing their location relative to other bodies are at rest. For example, a boy sitting on the chair, parked vehicles, water in a pond, they all are at rest. And rest and motion are relative terms. The same body is at rest with respect to one body and in motion with respect to another body. For example, passengers are sitting on their seat in a moving bus. They all are at rest with respect to each other. But all the passengers are in motion relative to trees, building, houses, outside. So rest and motion are relative terms. Now, bodies are found to be moving in different pattern. On the basis of moving pattern, Motion is divided into following types. Translatory or linear motion. The motion of a body along a straight line is called translatory or linear motion. For example, a bus is running on a straight road. Bullet fired from a gun. They are the example of linear or translatory motion. Next motion is circular motion. The motion of a body in a circular path is called circular motion. Earth moves around the sun, moon moves around the earth are the example of circular motion. The third motion is oscillatory motion. To and fro, or that means forward and backward movement of a body in a fixed point is called oscillatory motion. For example, pendulum of a clock. You can see pendulum of a clock move in oscillatory motion. Other examples are a baby in a cradle, swing are the example of oscillatory motion. The next motion is rotatory motion. The motion of a body about an axis is called rotatory motion. You can see the fan. The blade of the fan rotates about an axis, so moving fan has rotatory motion. Rotating itself is an example of rotatory motion. Spinning top spins about its axis, so spinning top has a rotatory motion. The next motion is spiral motion. Spiral motion, the motion in which a body shows both linear and rotatory motion at a time is called spiral motion. For example, sharpener is used to sharpen a pencil. Screwdriver is used to tighten a screw nail. Snake climbs on a tree. It shows both linear and rotatory motion at a time is called spiral motion. Now, last motion is random motion. The motion of a body in which it has no fixed direction. That means it moves randomly is called random motion. For example, motion of a bee, motion of a mosquito are the examples of random motion. Based on the previous topic, you can identify the types of motion. A fired bullet has which type of motion? A fired bullet runs along a straight path, so it has linear or translatory motion. Earth moves around the sun. Earth moves around the sun. This is sun and earth moves around the sun. That means it has circular motion. Spinning top. Spinning top spins about an axis. So spinning top has rotatory motion. A boy in a rotating. A boy in a rotating has circular motion. But rotating itself has rotatory motion because it moves about an axis. A baby in a cradle. A baby in a cradle moves forward and backward, so it has oscillatory motion. Motion of bee. Bee moves randomly. They have no fixed direction, so bee has random motion. A snake climbing on a tree. A snake climbing on a tree has both linear and rotatory motion, so it has spiral motion. After reading this lesson, you can explain, you can define the following term: rest, motion, force, effect of force, and types of motion. Now, types of force. Pulling force. The force which pulls or tries to pull a body is called pulling force. For example, when we pull water from well, we use pulling force. Bullock pulls a cart, it also uses pulling force. Second, pushing force. The force which pushes or tries to push a body is called pushing force. While closing the door, we use pushing force. An ice cream vendor pushes the cart We also use pushing force. Now third number, centripetal and centrifugal force. The force which acts towards the center and keep the body in circular path is called centripetal force, as well as the force which acts away from the center while moving in a circular path is called centrifugal force. Tie a stone with the thread and move around it. A force acting toward the center is called centripetal force. When I release the thread, what happened? It moves away from the center. Yes, this is due to centrifugal force. So, centripetal force, due to centripetal and centrifugal force, Earth moves around the Sun, Moon moves around the Earth. Fourth number, magnetic force. The force by which a magnet attracts magnetic bodies is called magnetic force. Now 5 number, gravitational or gravity force. The force of attraction between two bodies is called gravitational force. Due to gravitational force, all planets, satellites move around the Sun in their own orbit. And gravity force, the force by which all the objects attracted towards the center of the earth is called gravity force. For example, fruits falling from a tree. When you throw a stone upward, it comes back to the ground. This is due to gravity force. Next, frictional force. The force which opposes the motion of a body while rubbing two surfaces is called frictional force. Frictional force is advantageous as well as disadvantageous for us. Now, advantage of frictional force. Due to frictional force, we can light a matchstick. Due to frictional force, we can write properly. And we can also walk properly due to frictional force. And disadvantage of frictional force. Frictional force heats up the machine. It reduces speed of the machine. It causes wear and tear of machine. Disadvantage of frictional force, it causes wear and tear of machine. It heats up the machine. It reduces speed of the machine. Now, scalar and vector quantity. Those quantity which has magnitude, that means value. That means only value, not direction. Those quantity which has only magnitude, not direction, is called scalar quantity. For example, distance and speed are a scalar quantity. In vector quantities, the quantity which has both magnitude and direction is called vector quantity. For example, velocity, displacement. Now, distance and displacement. Your house is here and your friend's house is on another place. You use two paths to go there. First in this way or second in this way. When the path traveled by a body in any direction, it has no fixed direction. The path traveled by a body in any direction is called displacement. And the shortest distance traveled by a body in a fixed direction is called displacement. So, distance is a scalar quantity, displacement is a vector quantity. Distance has magnitude only value, but displacement has both magnitude and direction. Now, speed. The rate of change of distance is called speed. Rate means divided by time. Distance is divided by time. The rate of change of distance is called speed. Or in other words, the distance covered by a body per unit time is called speed. The formula of speed is distance by time. SI unit of distance is meter and time is second. So SI unit of speed is meter per second. Speed is a scalar quantity. Speed is a scalar quantity. Why? Because it has only magnitude, not fixed direction. Now, velocity. Velocity is the rate of change of displacement. Rate of change of displacement. Displacement means it has both magnitude and direction. So velocity is defined as rate of change of displacement. The velocity is equal to displacement by time. Rate means divided by time. Displacement by time. That means velocity is rate of time divided by time means rate. The rate of change of displacement is called velocity. SI unit of displacement is also meter and time is second. So SI unit of velocity is meter per second. Velocity is vector quantity because it has both magnitude and fixed direction. Now, uniform velocity. When a body covers equal distance in equal interval of time, it is called uniform velocity. And when a body covers unequal distance in equal interval of time, it is called non-uniform velocity. Acceleration. Acceleration is the rate of change of velocity. When two bodies are moving in the with the same velocity, that is uniform velocity, the acceleration of that body will be zero because there is no change in velocity. So acceleration is the rate of change of velocity. Acceleration is rate of change of velocity, that means final velocity minus initial velocity divided by time. So rate means divided by time. The rate of change of velocity is called acceleration. SI unit of acceleration is meter per second square. Now retardation. Negative acceleration is called retardation. If consider a boy moves from home to school, he covers 2400 meter distance in 240 seconds. What is his speed? Now we have already studied that speed is equal to distance by time. Distance by time. He covers, here mentioned, he covers 2400 meter. The distance is 2400 meter and the time taken by him is 240 seconds. 240 seconds. Cancel 0, 0 and 24, 1 are 24, then it is 10 meter per second. The speed of the boy is 10 meter per second. Now a car starts to move from rest. Rest means it has initial velocity is 0. A car starts to move from rest, that its initial velocity is 0. Now its velocity becomes 50 meter per second. Final velocity is 50 meter per second and the time taken by the car is 5 seconds. Now we calculate acceleration by this formula. A is equal to V minus U by T. Final velocity is equal to 50 meter per second. And it starts to move from rest. So its initial velocity becomes 0. And time taken by a car is 5 seconds. So acceleration of the car is 50 minus 0 divided by 5. That means 10 meter per second square. The acceleration of the car is 10 meter per second square. Now we can find many more questions from here. For example, difference between distance and displacement. The path traveled by a body in any direction is called distance. The shortest distance traveled by a body in fixed direction is called displacement. Distance is a scalar quantity, displacement is a vector quantity. Speed and velocity. The difference between speed and velocity. The rate of change of distance is called speed. The rate of change of displacement is called velocity. They have same SI unit, so it is not a difference. So speed is a scalar. Second difference of speed is it is a scalar quantity and velocity is a vector quantity. The acceleration of a car is 5 meter per second square. What does it mean? The acceleration of a car is 5 meter per second square. It means the velocity of the car increases by 5 meters per second in every second. The retardation of a car is 5 meters per second square. In what does it mean? The retardation of a car is 5 meters per second square. It means the velocity of the car decreases by 5 meters per second in each second. Now, calculate the amount of force required to produce motion in a car of 1000 kg with an acceleration of 5 meters per second square. That means 1000 kg means mass is given. The SI unit of mass is kilogram. So 1000 kg is the mass and acceleration of the car is 5 meters per second square. Meter per second square is the unit of acceleration. So acceleration of the car is 5 meters per second square. Now we have to calculate force. We have already studied the formula of force is mass into acceleration. The mass of the body is given 1000 kg. The 1000 multiplied by acceleration is 5 meters per second square. 1000 multiplied by 5 meter per second square. That means 5000 kg meter per second square. Kg meter per second square is Newton, also known as Newton. So force required to produce motion in a car is 5000 Newton. Now next, a force of 30 Newton is applied to a body of mass 6 kg. Calculate the acceleration in the body. 30 Newton is force. The force applied is 30 Newton and mass of the body is 6 kg. The force is equal to 30 Newton. Mass is equal to 6 kg. And what we have to find out? Acceleration. Acceleration we have to find out. We know formula of force is equal to m into a. Now a is equal to, or we have to write a is equal to f by m. Acceleration is equal to force divided by mass. So we apply formula acceleration is equal to force divided by mass. That means force is 30 Newton. 30 Newton divided by 6 kg. In place of Newton, we can write kg meter per second square. 6 5 are 30 and kg cancel. So we have 5 meter per second square. Acceleration of the body is 5 meter per second square. This much for today. Till then, bye.